Welcome to the On-Premise IT Roundtable podcast, the only show that dares to be both on topic and on location, or on-premise and on-premises. Each time we meet, we bring together a group of IT luminaries to discuss a single concept or premise. In this episode, we're discussing composable infrastructure. Is this just another buzzword for blade servers? Is this just the next generation blade? Or is this really a radical difference? I would love it to be a radical difference, but frankly, looking at a lot of the products, it's just blade servers 2.0. Before we begin talking, let's meet the panel today. I'm Stephen Foskett at sfoskett on Twitter.
Hi, I'm Chan EK81 on Twitter.
I'm Enrico Signoretti, A Signoretti on Twitter.
So let's talk about this. So composable infrastructure is, it's one of the big buzzwords. It's a lot of companies are talking about it, and it sounds like a great idea. You know, Chan and I were talking about it before, and you said something which I really enjoy. That basically it's infrastructure that software can reconfigure. It's dynamic infrastructure with APIs and integration and so on. That sounds like a new thing, right?
It is and it is not. HP started that back in the days with Flex Fabric, if you ask me, really. Putting an API in front of hardware and making it modular is what essentially defines composable or kinetic infrastructure to me, really, regardless of whether it's blade or rack mounts.
Enrico?
So I think that all this composable infrastructure, or at least this generation of composable infrastructure, is just Blade 2.0. I'm not. So my problem is today that if I look at the product, so they are all limited products, and they are limited to a chassis most of the time. So and when I think about composable infrastructure, just the word infrastructure is not composable chassis. Infrastructure for me is a world data center. So we are missing something here. Maybe it's just that this is the first generation of product. But yes, maybe the second generation after Flex Fabric, after the first generation of UCS, after Dell, whatever, I don't remember now. But that's a problem. It's just marketing at the moment.
Yeah, that is correct. I think if you look at what the composability means, at least to me, what virtualization did to compute, abstracting that identity into a virtual layer, doing that hardware. One of the underpinning requirements for that is the backplane, or what we call the backplane, or the connectivity between those different infrastructure nodes. And it's easier to do that with a chassis, with a blade infrastructure. Right now, Dell's just proven that you don't have to do that with the launch of MX, where there's no concept of backplane. So as the technology evolves, I think you'll probably see the next generations having different rack mount infrastructure with connectivity backplane. That'll bring that closer, so you can start doing composable or kinetic infrastructure provisioning on demand at a modular level, regardless of which frame or the sled or the piece of tin that it resides on, in the way that the blades let you do that today.
Yeah, but my problem is, okay, blade or not blade, whatever. If I don't want to have the lock-in, okay, so even if the Dell technology is good, for me, composable infrastructure is that I can buy whatever server I want, I can buy whatever storage I want to combine them in the way I want, okay? Meaning that if it's a data center-wide composable infrastructure, I want, a software layer or whatever it is, standard APIs, put it in the way you want it, but I want something that I say, okay, this week I want to buy 100 super microservers, the next week 100 Dells, and they just have to work together.
So what are these essential components of composable infrastructure? Because it seems to me that, we've heard about heterogeneous, basically buying from different vendors and different components that should work together. We've heard about integration.
Yep.
We've heard about dynamism and flexibility. What are the things that it needs to be in order to be composable infrastructure?
For me, I think having the API or the ability for software to interact with the hardware and its lifecycle operations via an API is priority number one. Without an API element, that's not composable.
I could see that.
Yeah.
So, that's kind of the table stakes. If you can't, if software can't talk to it and control it through an API, standard API, then it can't be composable. Okay? What about multi-vendor?
So, again, standard API, so multi-vendor, no longer a problem. Okay, maybe you have different resources from different vendors, and you can treat them differently. Okay, but anyway, there are new protocols now, like NVMe or NVMe. Sharing an NVMe device now is way easier. We had the proof a few weeks ago at a TechField Day event that these guys brought a very nice example. So an NVMe device is shared to a remote server. That's great because means, okay, I can just go on the other side of the data center, borrow these resources, attach them to my server or whatever, and that's it. Okay, and also for the networking stuff should be something similar. So yes, standard APIs that work for everybody. I know that we are very, very far from that.
I think from a multi-vendor standpoint as well, it's important for it to be truly composable across all the vendors. That standardized interconnectivity.
Well, that begs the question. It reminds me of software-defined networking, SDN. Is SDN a requirement of composable infrastructure?
I don't think it is today, and I'd probably even argue that it's not just SDN, it's the actual hardware fabric, be that InfiniBand networks or be that some sort of a I/O pass-through module, whatever that could be, that is standard, something driven by SNIA, for example, that all the vendors can partake in. That would be the biggest enabler for us to have that multi-vendor composable infrastructure.
Could it be that we need a different kind of networking hardware to make the I'm not a networking guy, so maybe I'm out of my field, but actually, so composable infrastructure at the networking level. So I can see it at the storage level with NVMe, okay, with the evolution
Fabric,
that
NVMe over Fabric.
Yeah, this kind of technology, okay. Maybe we need to find something at the networking level to reorganize the layer 2 of the infrastructure. Because when you think about SDN, you think about upper layers, okay. So dynamic reconfiguration and virtualization of the upper layers. But actually, we are thinking here about connecting physical resources. So we are at a lower layer, and maybe we need a new concept of layer 2 SDN somehow.
I think it's probably even a level further up. We're probably talking connecting different SOC on chip, SoC architectures at a hardware level, so that something like Synergy, for example, can have a connectivity to use some of the resources from a MX platform or something. I'm just using examples out of the products that are available today. But what if we have a common framework where they use those technologies to bring the hardware ecosystem together? For example, the HPE Machine project was talking about using photonics to bridge that gap between CPU and memory. What if you can have CPU and memory from different vendors all talking to each other through some sort of a open standard photonics platform? That's what's going to be a genuine multi-vendor composable infrastructure to me.
Yeah, but we are back to the fact that these are not standard approaches. So do we have to wait Intel and AMD stepping into the game and build some sort of standard so that everybody can build on top of the standard their product? Because without questioning the quality of this implementation today, they are, they are not standard. Yeah. So they are designed by a team that doesn't talk with the other
that teams. Has a vested interest in promoting their own. Yeah, absolutely. I think that's a question for SNIA, really. Be very interesting to see whether SNIA is actually working on anything similar.
Well, and that's and maybe not even SNIA too. I mean, the thing is, you've also got composable infrastructure based on PCIe fabrics.
Yeah, correct. Yeah.
Certainly you've got composable infrastructure based on Ethernet. That's why I bring up SDN. Yeah. You mentioned photonics. You could also say that technologies like the Open Compute, Facebook servers, are potentially enabling this kind of stuff. We do, because you do need some kind of flexible backplane. Because the idea is that I think ideally, what it seems to me is that composable infrastructure would require you to have some sort of disentanglement of compute, storage, I/O, maybe memory, I don't know, storage class memory. You can mix all this stuff in here so that you can kind of mix and match and build a server as you want. So it's kind of like hardware, except it's like virtualization, but in hardware. Sort of.
Hardware as a service.
Yeah, and all these things kind of go into that.
Yeah.
And that's why, maybe it seems like maybe it's not just the next generation server. Maybe this really is a revolution. You mentioned HP's The Machine. What a crazy name,
Yeah.
That's exciting stuff. I don't see it though.
No, not quite. I think while the vision of the composable infrastructure is great and the possibilities of what you can do for it to be genuinely composable is yet to pan out, the current implementations are pretty much driven by each of the vendors through their PR engines and the marketing engines to favor their own. And it's limited in terms of what they advocate there. It's limited by their generation 1 capabilities. Mm-hmm. And it's important for us to also understand that the current composable benefits that you see and read from all the key vendors and their PR engines coming out, marketing messaging coming out from the engines, are not really talking about the true benefits of composable infrastructure. They're more about just next generation hardware evolution that everybody has, not just composable fabrics infrastructures, but even legacy, rack-based compute platforms. They all have the same. So you need to distinguish between the two as well.
Yep.
I think that if we don't reach the rack scale or data center scale kind of composable infrastructure, it's not really composable.
Correct.
So now all these guys are talking about their new product, which is better than the older one, which always happens, of course.
Yeah, surprise, our new product is great.
Yeah.
Our old one kind of sucked.
And but again, it's back to the initial point. It's a better version of the debate. We are not ready technically, and probably also the customers are not ready. And there are very few customers today that are ready to embrace that kind of data center redesign.
Exactly. And they also have the other threat of the cloud platforms that take that composability outside of hardware and implement that in software to a large level. So most of these data center vendors have to up their game a little bit. So I think for me, taking a step back a little bit, the whole concept of composability or the kinetic infrastructure kind of emanated from that as well, where people can just spin up any resource, be that compute resource, as a VM, or be that a microservices resource, solution on a platform where they don't have to manage infrastructure, or it could be something like serverless. So there's so many choices when it comes to running their content. And on the data center world, they haven't really had that. You always have to have a server. You always have to have a VM as a use case. So composability is another attack, I suppose, or another way of the data center vendors upping their game a little bit. Whereas for me, the true composability means all of those things that we talked about earlier, and that's a few generations out, if it ever happens.
One of the things you just mentioned actually spurs a thought in my head, and I think that it's worth discussing now. Is composable infrastructure the exact opposite of serverless? In other words, serverless, the whole thing that you're doing is you're creating, it's not truly serverless. Yes, we know there's a server. Thank you for pointing that out. But the whole point of serverless is that you're creating services that can run anywhere and that can be distributed and that can scale massively. You could have thousands of instances or one instance that they can all work together with a coordinating application.
Yep.
And so basically, it is serverless in that they're just functions, and you just call these functions as needed, and the functions run anywhere. Serverless doesn't need fancy hardware. It doesn't need, specifically, it doesn't need composable infrastructure.
Yep.
Are these things the exact opposite approaches to try to do the same thing, which is to make things scale and flexible?
I don't think it's true, in the sense that serverless is a programming approach at the end of the day, okay? And probably you need specific resource to run functions, okay? But if you are a large service provider, and you want to build your infrastructure, you need databases, you need virtual machines, you need specialized machines that run serverless workloads. So you want to optimize your infrastructure in real time. So if today you see that there is a growth in serverless function, okay, you assign more hardware resources to that, and tomorrow maybe you can remove some of these resources, okay? And these machines are different from database machines, because probably to run serverless you need more RAM, more CPU, but probably no storage or little storage, okay? So I don't think they are in opposition to each other. I think that it's that serverless or all the other services that service provider is running, okay, are a perfect match for composable infrastructures.
I think they're not mutually exclusive, is what I'd probably say. There are different tools in the box that the customers have that they can use to achieve different things differently, but they can also work together. You made a good point about, Enrico, about the fact that if you had a composable infrastructure and a serverless or a function as a service platform running on top of that, depending on the demand, you can reallocate additional hardware, compute, memory, and storage resources on the fly to those serverless fabric. So they can be used together as well, but I think there are different ways of.
But is it even important to do that? I mean, I don't know. That seems totally pointless. I'm sorry, but if you've got a web scale if you've got an environment that can host web scale applications and you can build function as a service on it, who really cares about dynamically allocating memory? Just make a whole herd of cattle and redeploy the whole cow, not just the cow's left side.
That assumes then you have an infinite pool of hardware resources underneath, right? And while that may be true in a cloud or a mega scale platform, for the average customer or the average enterprise that has a finite hardware resources where it's shared across different use cases, different teams, et cetera, I think that reallocation of resources still could be a viable choice, because they don't have the ability to just create additional functions and then place them elsewhere for it to be executed.
They're not web scale, and they're also not function as a service, so they're not serverless. They'll never be serverless. Yeah. They just need some resources.
Well, we can also think about the fact that if you have a data center that is as large as a football field, you want everything at perfectly efficient all the time. And if the cost of having a composable infrastructure is similar to a traditional infrastructure, why not? So it comes to the cost. Okay, if I can buy x86 standard server for a very low price and the composable, part of it costs me twice. Well, maybe I'm not the guy that I buy these kind of things because I have so many servers that it doesn't make any sense. But if it costs the same and I can tune everything, and when I have a new service or workloads that need the kind of resources, just a little bit of tuning on the infrastructure and it works. So it will come later when this kind of discussion will come later when we will know how much does it cost to have this kind of infrastructure first, and when we will be able to build an entire data center that is composable.
So is composable, who's the customer for composable? Is it enterprise or is it hyperscale?
Definitely enterprises for me.
Got it. You agree?
No.
Oh, you can't even agree on that. Okay.
No. So if you have a rack scale kind of composable infrastructure, maybe, but I see the very big advantage of this kind of technology in larger infrastructure. So it's about the size of the infrastructure. So sure, it's not the chassis level, probably rack scale, enterprise, larger configurations, hyperscaler, web scale kind of guys.
I think if you look at the need for the invention of, outside of the PR necessity of having to have a credit, something new to combat the threat of cloud platforms, outside of that, if you look at the reasoning for composable infrastructure, it is to find a solution for that resource imbalance at the hardware level, right? That's their main play. At a cloud scale platform, the need for that, for me, is very less because of their economic model and the scale they have and the ability that they have within software to go into very modular distribution of resources, hardware resources. So that's why, for me, it's probably not really that applicable for the mega scalers, because they can afford to have that resource imbalance because they'll fill those imbalances through software innovation. Whereas enterprises don't have that level of dev capability unless you're a massive enterprise that can spend the same R&D as AWS or Azure, where for them, having the ability, just like you can increase virtual RAM, virtual CPU into a VM, having the same flexibility at the hardware layer is more relevant to them.
Yeah, we already discussed that on this podcast, is you're not Facebook. Why are you trying to pretend to be Facebook?
Exactly.
If you're an enterprise, you need a different kind of approach. And I really agree with you, Chan, on this one. I think that it really is a great solution for enterprise. Honestly, I look at Composable more as virtualization 2.0 than as Blades 2.0.
Very correct. Yeah.
Am I wrong about that, Enrico?
No. So if we take it as if it works, and at the RASC scale, I agree. It depends on the cost anyway. If it will be too expensive, then no hyperscaler and probably neither the enterprises will adopt it. If the cost is similar to traditional approaches, or just that bit that makes it interesting, then yes, I agree that enterprises at the RASC scale and large organizations, larger data centers at the data center scale will adopt it. It's a huge paradigm shift in the way you design and consume data center resources.
Final word?
No, I really like your analogy of likening the composable infrastructure to virtualization 2.0 for hardware. That is very true. I agree with that. I would like to see the community of vendors working together, like we discussed initially, to provide that hardware abstraction and the interoperability across different platforms, maybe through SNEA or through some open compute platform, to extend the true composability out of the hardware infrastructure to be multi-vendor. Until then, for me, it's called limited use cases.
Enrico?
I totally agree.
And I agree too. Thank you for listening to the On-Premise IT Roundtable. If you enjoyed this discussion, remember to subscribe, rate, and review the show on iTunes, since that really helps our visibility. And please share the show with your friends. Again, we're on Twitter at OnPremiseIT. You can also find us at Gestalt IT, and this podcast was brought to you by Gestalt IT, your home for IT coverage across the enterprise. For show notes and more episodes, go to gestaltit.com/podcast. Thanks, and we'll see you next time.